starting with this, okay? Oops, I didn't mean to start with this. I want to go back to the calendar. So per you guys' requests, I put when we were going to do homework checks so you can see it in green. So next week is kind of a big week. I understand. There are, number one, a lot of people out today. There are a lot of people that are probably going to be out for various reasons next week. This is what the calendar is. Should anything happen with the weather, I'll update the calendar when we have a plan. Okay? Should you not be here, we will miss you, but we are marching on. So if you are not here, then you need to be checking your email and watching these videos that I'm making right now so you can at least learn the material, okay? Because you do have a test on Thursday. You should have everything that you need at this point if you're going to be out next class, because the review is tacked on to the homework page. So your review is technically the 8.3 problems. You just need to watch. It probably won't even be that long of a video, honestly, because it's just more solving with some different types that we need today's lesson to kind of make us understand how to do. So the expectation is that you are going to be ready for that test on those days. And if you're not, then you need to be coming into tutorials next week. So we will take a CFU over the lesson I'm about to teach you on next class. It will be short. I know, like, if you look at the homework problems for 8.2, I kind of pointed this out last time. There's a lot. 8.1, there's only 7. 8.2, there's a lot, but they are really quick. You'll see that these problems, like, some of them are like this in the notes. Like, they're very fast. The evaluates have a little more mental math. However, they still are way faster than these. So even though there's a lot, they're quick. You are going to have questions like this on your test, and they're pretty much like no partial credit. They're right or they're wrong, but there should be gimmies, okay? And then, yeah, it is easy. And then, like I said, this is the review. So if you're here today, you should have everything, even if you're absent next class. Just watch the video. And then be ready for that test, and that test is 1 grade. I will check the 8.3/review before we take the test and have time to take questions. Does everyone understand? I also will probably post, I have an answers only sheet. I have this with me. I have the work with me if you can't figure out the actual work or you're lost or something. But I will post the answers only on Canvas next week for you to check those. But then if you need to look at actual work, you need to come in and see me at some point. Okay? So this lesson we're going to talk about today is really not any solving. We're kind of taking like a little time out from solving. But we need this lesson before we get to our next type of solving. It is pretty easy. We do have to kind of go back to some exponent rules, which Algebra 1 was the last time probably that you saw these. It may not have been your favorite time. If you ask my freshmen who learned this yesterday and this morning, they probably would tell you it's not their favorite either. But it is really important. So we're on page 5. This front page is all basically Algebra 1 review. The next 2 pages are going to be kind of like actually how we use this and why we use this. But I think this will also clarify for some of you, like, I'll be able to prove to you why some stuff works the way that it does. Like, for instance, why does squaring both sides undo a square root? I'm going to be able to prove that to you today, specifically why, okay? So join me on page 5. Again, this is kind of Algebra 1 review, but you really won't see it much, and pre-cal is going to expect you to kind of know how some of these exponents work. Can we close our Chromebooks, please? Okay. All right, so the first one is the product property. So product means multiplication. So if you happen to be multiplying with like bases, that means they both have to have the same base. That base can be a variable, that base can be a number, but when they're the same base, then exponent rules say, what do you do with those tiny little exponents? You add them. So your base stays the same, and then it becomes m plus n. So that's with exponents, okay? Add those up. The power property is where you have a power raised to another power. So we would have something in parentheses and an outside power like that. What do you do with those? You multiply. So this becomes a to the m times n. My little Algebra 1 kids have been saying you like distribute it in, which is true because distributing is multiplying. But you can only multiply exponents to exponents, okay? A product to a power, so this is pretty similar, but this is, hey, what if you have more stuff going on inside the parentheses that's raised to a power? Well, guess what? That, quit. That exponent is just going to go into all the exponents that are in there. So and all the bases that are in there. So this would be a to the m times b to the m. Okay? And of course, if those products or those bases had exponents in there, they would multiply there. Your quotient property is technically you have a division problem. A lot of times they're set up as a fraction. What do you do with your exponents there? Subtract. Technically, the rule is subtract. The way I kind of talk about it in Algebra 1 is like tug of war. Like we'll look at, okay, who has more of that base? Technically, they're doing a subtraction, but, sometimes with subtraction, you could get negatives and you have to move them. So sometimes I just think about it as like, where are there more on the top or the bottom and how many more? Zero exponent, anything to the zero power is?
0.
No. 1. Man, last class everybody said 1. This class everybody said 0. Not everybody, but a lot of people. Okay? Anything to the 0 power is 1. So essentially, if you see a 0 exponent, whatever it's attached to is just going to become a factor of 1. Most of the time, you don't have to write it unless it's like literally the only thing left. You would have to put a 1, but be careful of that. And then quotient of power, so again, with that outside power happening, if you've got things that are being divided, again, the outside power just comes into everything. So I'd have a to the m over b to the m. One that's not on here that I think is worth writing in would be your negative exponent property, which what that says is if you have a base raised to a negative exponent, we don't really like that. It's not fully simplified. So what we do with those are we move those bases to the other side of the fraction, and then our power becomes positive. Now, if there's nothing left on the top, you do have to write in a 1, so that's why the rule is written this way. However, if there is something else on the top, you don't have to write the 1. Yes?
When you use the quotient to a power property, do you do the so there's kind of the quotient property? Like,
Wait.
do you use that? Like, do you do the n minus?
What did you say?
So like the last one, that n divided by b.
For, fun times, let's go over these warm-up questions again, and then we'll actually get to, like, the new stuff here. I'm going to go a little bit out of order. I'm going to do number 2 first because it gets a little bit easier. What operation is happening between your terms on number 2? Multiplication. So I'm going to be using my product rule here. Okay. Product rule. So this is what I said this morning in Algebra 1, probably 10 times. Regular numbers follow regular rules. Exponents follow these rules. So what gets a little bit tricky about some of these is we can kind of mix some stuff in. So the way I always think about these is I try to just go like one rule at a time, one base at a time. So the first thing I would look at is this coefficient of 3 and this coefficient of 2. Those are not exponents. Those are coefficients. Those are regular numbers. And what do regular numbers follow? Regular rules. So this is a multiplication problem. Therefore, I just multiply 3 times 2 and I get 6. Okay? Then I move to my next base, which my next base is x. X to the 3rd, and I'm going to underline x to the 5th over here, and I'm just going to focus on those right now. Okay? I dealt with the coefficients. Moving on. Deal with the x's. Now I have exponents, and exponents follow the rules that I just wrote down up here. So if I follow my product rule, because this is a multiplication problem, what happens here? X to the 3rd times x to the 5th. I keep the base. What do I do with the powers?
Add.
3 plus 5 is? 8. Done. Okay? Now I deal with the y's. Write down base y. What is 1/4 plus 5/4? If you remember with adding fractions, you have to have a common denominator, which you're welcome, you already do. That common denominator stays the same. You work across the top. 1 plus 5 is 6. Can you reduce 6/4 to what?
2/3.
3 halves. 3 halves. And then this is our answer there. Okay? You're done when you have like one of everything. One coefficient, one base x, one base y. All right, let's look at number 3. We're going back to number 1. I just wanted to go out of order. I don't know why. Okay? Yeah. Okay, all right, number 3. What kind of operation is happening on number 3? Division. So you're using your quotient rule. Now, there's a couple things going on number 3, okay? First thing is, do we have coefficients? Do we have regular numbers here? Yes, and regular numbers follow regular rules. So with the 3 over -18, technically you are dividing those. I don't always say divide because they may not divide to a whole number. Reduce it, okay? So 3 divided by -18 reduces to what? 1 over -6, -1 over 6. The negative can kind of float wherever, okay? But I'll just keep it in the denominator. So reduce that fraction. If it's a whole number, great. Put it in the top. If it's not, just reduce the fraction. Now, a couple other things here. First thing is I see a z to the 0. What's anything to the 0 power?
1.
So do I need that there? No, it's just a factor of 1. It's not changing anything.
So z is just 1?
No. Z to the 0, like there's no more z. It's just that is 1. We don't need to write it, mark it out, it's gone. Okay? With the, I will, you know where the video will be, right? On Canvas. Do you want me to email it to you?
Yeah.
Okay. With the negative exponents, because do y'all see a negative exponent on here? Where, what's attached to a negative exponent? X. Okay, so again, this is not the only way you can do this. This is just kind of how my brain works. I like to, beforehand, if I have a negative exponent, I like to fix it. I like to move it, go ahead and make it positive, and then apply my rules. This is not the only way you can do it, but I think it gets a little bit tricky, especially with like subtracting negatives and things like that. I don't know, just I'd rather move it. So right now, base x, it is in the denominator with a negative exponent. That can't happen. So to fix it, where do I need to move base x? To the numerator and then make the exponent positive. So I can go ahead and fix that. But now I have an x to the 3rd and an x to the 4th on the top. That's a multiplication. So what do you do with those exponents? If you ever move a base to the other side, the sign of the exponent will change. I would never make an exponent negative, but I would move it to make it positive. Okay? And then here, I'll show you the tug-of-war thing here. Y to the 8th over y to the 12th. Technically, if you subtract those, what's 8 minus 12? So where does the y technically need to go? On the bottom with an exponent of 4. But again, this is the tug-of-war thing I was talking about in Algebra 1. We would look at this and say, okay, who's going to win this battle? The top or the bottom? And they would say the bottom because there's 4 more y's on the bottom. So that's why y to the 4th goes in the denominator. So whatever way you want to think about it. I think that's fairly easy to think about it that way. But truly, the rule says to do your subtraction. So there's that. And you don't have to have the 1 in front of the x to the 7th. The only time you have to write a 1 is if there's nothing else left. Okay? All right, one more. What rule are we going to use on number 1? It's technically called power to a power, but I sometimes just call it the power rule. This one means you're going to take the outside, product to a power, yes. This means you're going to take the outside exponent and multiply it to every inside exponent. What is x's exponent? 1. I sometimes will write them in if like they don't have 1. There's an understood 1. Here's the other thing that gets messed up a lot. This 4 right here, is that an exponent?
No.
So can you multiply an exponent times a regular number?
No.
What is 4's exponent?
1.
So you are multiplying 3 into 3 separate bases, 3 separate exponents there. So this would give me 4 is my base, 1 times 3 is my power, and we're going to clean that up in a minute so we can actually evaluate that. But over here, this is going to become x is my base, 1 times 3 is 3, y is my base, 2 times 3 is 6. I can't do anything with x to the third, y to the 6, but what is 4 to the third power? 4 times 4 times 4. You need to be able, here's what's going to be hard about today. You have to know how to do mental math, okay? You have to know how to raise things to certain powers. You have to know how to take roots of certain things for this. And you'll kind of know what I'm talking about here in a minute. Okay? Yes?
So
Everything that we're doing today is going to build so that way we have all the tools we need to solve the types of problems that we haven't seen yet. Okay? All right, flip over. We got 2 more pages to get through. So there's one more... There's one more exponent rule that technically is on a formula chart if you were ever looking at a formula chart. I don't even know if they have those anymore for Algebra 2. I'm sure there's one for the SAT. But there's one more exponent rule that we have a little picture of here, but I'm going to just kind of write it out so I can talk through it real quick. But it has to do with rational exponents. Now, I want you to understand vocabulary here because I'm going to be throwing around the word rational and radical, honestly, for a while because we're in a radical unit. Our next unit is specifically about rationals, but I'm talking about both of them today. When you see rational, that is the same thing as a fractional. So if I say I want you to write this as a rational exponent, I want your exponent to be a fraction, okay? That's what I'm looking at there. If I say radical, radical's got to have a root. Radicals are roots, so I would want you to have like a square root, a cube root, or whatever root in there. So you can have exponents that are fractions, and you can rewrite them in both ways. And I'm going to ask you to do that on your homework today. I'm going to ask you to do that on your CFU. I'm going to ask you to do it on your test. It's a give me problem, okay? But then we're actually going to use those skills and not just rewrite. We're actually going to be able to evaluate things by rewriting. This is where we're going. So I need you to kind of hang with me for a minute. So what's written right here, I'm going to kind of write separately and talk about it like one thing at a time so you can really see where stuff is going because this honestly just kind of seems like a lot to me, okay? So how it's written, at least on the Algebra 1 star chart, again, I don't really know what y'all's formula charts would ever look like, but it's like this. You have a base. That base can be a number. That base can be a variable, whatever. Base can be a product of numbers and variables. We're going to see all those today. But you have a power that is written as a rational, aka fractional, m over n. As long as these are integers, which means whole numbers, m and n are whole numbers, and n is not 0, then this rule holds true. This is the same thing. This rational fractional exponent is the same thing as doing the following. Watch the order that I'm doing this. The nth root, okay, go ahead and just put that down. So that could be a square root if the denominator was 2. That could be a cube root if the denominator was 3. A fifth root if it was 5. Pay attention. It's coming from the denominator. The denominator tells you what type of root of the base, which in our case is a. That base could be a number. It could be a letter. It could be a combination of that base. Then it's raised to the mth power. M power, as in McCartney, okay? That power on the outside comes from the numerator. So I wanted to break it down, bless you. So you could see the denominator tells you the type of root. The numerator tells you what it's raised to, okay? And here's some vocab for you. I think there is a question in your homework that asks about vocab. The index is what type of root you're taking, and I do refer to those as like odd or even a lot, especially next class. So if I throw that word, that's what it means. The radicand is what's like your base. That's what's on the inside. If you see anything with vocab, just know it's on page 6. And then the exponent is there. This can also be written a couple of ways, just so you are aware. A lot of times if I rewrite, I separate my radical and put my outside power like outside of parentheses. But if you don't, I wouldn't count it wrong. And then sometimes it can even be written to where you have that outside power under the radical, but these are all three the same thing. And we'll talk about how they can work either way when it comes to actually plugging in actual numbers, but they all work all the ways, okay? So that's the rule. Get comfortable with that because, again, rewrites, you got to know how to do it. Evaluates, you're going to have to rewrite to actually do it. So you will have, again, CFU, homework questions, test questions that specifically just say rewrite, which means you're not really doing any math with it. You're just strictly changing the form. So rewrite this as a expression with rational. What does rational mean? Fractional exponents. Okay? So let's do this first one. This is the square root of x to the third. Now, honestly, I kind of think this one is a little bit trickier than this one because here's what people forget. What is the index of a square root? 2. The index is a 2. Now, usually when we don't write stuff in math, it's an implied 1. But for this, it's actually a 2. You won't really see it written in, but if it helps you to write in, then by all means do that. So this is a square root of x raised to the third power. So if I rewrite it, I always start with my base. My base is going to be what's underneath the radical, which is technically the radicand. So x to the denominator of my fraction is going to be the type of root that I took, which is a square root. The numerator is going to be the outside power, which is a cube root. And that's my answer. Move on. Okay? So like I said, you've got like 6 questions that are just rewrites. Straightforward like that. What about going the other way? Rewrite the expression using radical notation. Radical means you're going to have some sort of root. Okay? So pay attention to the denominator. I'm going to set this up with what type of root? A fourth root. Why is it 4? Because 4 is the denominator. Of what's my base? So that's what's going underneath the radical. Then I'm going to raise that whole thing to the third. You can write it like this. You can write it like this. Or you can write it like that. All of those are acceptable answers. I don't need all 3, but they all will be counted right. Okay? Try these 2. And there may be some cases, especially if you get back to a fraction, if they can reduce. Like if you have, 10 over 4, reduce that. Just as much as you can. Sometimes they even divide evenly to a whole number. I think that happens on your homework as well. Okay? If they don't reduce, then cool. Leave them. So again, like I was saying, on your homework, you have several that just say rewrite. Like 8, 9, and 10 are rewrite. Now, they put numbers underneath, so like your bases would be numbers. Cool. Just make your base a number, where the example in the notes had X's, whatever. And then you've got rewrites here as well with bases that are numbers, okay? 11, 12, and 13, those kind of probably should be more in this bottom section, but whatever, that's neither here nor there, okay? So one little thing I want you to kind of see the relationship between this little table. We'll complete it below. We'll actually do the bottom row and then work our way up to the top. So let's start with the bottom row. What is 4 squared? 16, okay? How do we get that? 4 times 4. Okay, what is the square root of 16? 4. Okay, what is 16 to the 1/2 power? That is the same thing as square root 16, which we know is 4. So what essentially is going on is everything in this column and this column are going to be equivalent. They're just different forms here. Okay, so I want you to kind of understand the relationship between these here, and then I want to prove something to you. Yes? That's fine. It rewrote it and then found the number? Yeah, that's pretty much what I do. especially the harder ones. Okay, what about 3 to the third? Okay, you got to think about it. It's 3 to the third power. It's 3 times 3 times 3, which is not 9. It's 27. Okay? What is the cubed root of 27? 3. Therefore, what is 27 to the 1/3 power? 2 to the 4th power?
16.
The 4th root of 16.
2.
Therefore, 16 to the 1/4 is 2. Okay, and y'all are going to have to be able to figure this out in your head. If you are raising something to a power, you are just multiplying that something over and over and over again. That's easier. When you're taking roots, those are a little bit harder to do in your head, but you got to figure out what times itself, times itself, times itself, however many times gets you that number, and then that's what you get. Raising to a power, numbers should get bigger. Rooting a power or rooting a something, numbers should get smaller. Okay? Now, I said to you, now that you kind of understand this, I want you to be able to know why we have been undoing the square root of x by doing what? We did this last semester too. What undoes the square root of x? Square. Okay? What undoes the cube root of x? Cubing it. Here's why. Okay? We know this. We've been doing this for weeks. But I want to kind of show you why this works in case you're curious. If I were to rewrite the square root of x as a rational exponent, what is that? X to the 1/2. We just learned that. This is the index. This is raised to here. So if I just rewrite square root of x, that is x to the 1/2. Okay, well then we've been saying, okay, you undo that by squaring. Well, what does your exponent rule that I just reviewed on the first page tell you do with outside powers? You multiply. And what is 2 times 1/2?
1.
So this becomes x to the 1, which is the same thing here. So that idea as to, I know y'all have been like, they cancel, and you're not wrong. But what really is happening is you are multiplying and creating your exponent to become a 1. That's going to be a big idea next class. Because we're going to have to be undoing not just powers of 1/2. We're going to have to be undoing powers of 3/4 or 4/9 or things like that. And so the idea is you're turning it into a 1. So that's why this works. Tell your friends. Math is cool, right? Yeah. It's not too bad sometimes. Meh. Okay, let's do this. It's helpful. Here are a bunch of numbers on here. I don't want this to overwhelm you. I don't want you to be like, she's making me memorize a million trillion numbers, because guess what? Majority of these numbers you should know. I think this is just going to help you as you start to do these practice problems. This chart is not going to be on your test. You're going to be responsible for being able to figure out these numbers. But here's the good news. The first row, you already know, because what's anything to the 0 power? 1. So check off the first row. You already know that. The second row, you also know, because what's anything to the first power? Itself. So check that off. You should even know your squares, especially bases 2 through 6. So really, that should have a check mark. I'm going to draw a line to things that I feel like you should know very easily above that line. It's the ones below the line that for me, I might have to kind of jot down some work on my paper. But I know 2 to the 5th, easy in my head. I wouldn't, I have that memorized. I know through 3 to the 4th in my head. 3 to the 5th, I probably, to be honest, would have to write that down and multiply it. I'm not a human calculator. Some of y'all are. Good for you. That's not me. Okay. 4 to the 3rd, I would definitely, we see that one a lot. 4 to the 4th, again, I'd have to multiply. That's where I'm drawing a line. Of anything under the line, I would probably have to multiply out. But it's not that hard to do. You're just timesing it by another 4. 5 to the 3rd, I would definitely know. That's a pretty popular one. 5 to the 4th, I would have to multiply. I'd probably have to multiply 6 to the 3rd out if it were me as well. But if you think about that, if you're like me and these are the only ones you had to do, that's really only 1, 2, 3, 4 numbers that you shouldn't be able to do in your head easily. Okay? So it's not too much. But you might want to look back at these as we go through these. But here's the big idea, and honestly, we're just now getting to the whole purpose of this lesson, and we're almost done. Why do we need to know this? When is this going to come into effect? So what's going to happen next class is the types of radical equations that we're going to be solving are going to have these fractional rational exponents on them. And we're going to have to know, A, how to undo them, which that's like kind of the new part of next class. But we're also going to get to where when we undo them, we could have something on the other side of the equation like this. You could have x plus 5 equals 9 to the 3 over 2. And you've got to know what is 9 to the 3 over 2 without a calculator. Okay? So this is what we're about to spend kind of the rest of our time doing. Is how do we do this? And the technical instructions for what you're doing is evaluating. You're finding a value. And if you look at your homework, a lot of your homework says evaluate. Tell me what the value is of this. It's not solving because they're not equations, but you're telling me what the value is. And again, there's various ways we can word this. So we've kind of got a lot of practice problems here. They are kind of quick, but you got to know how to do that. Okay? So without a calculator, what I think is the easiest is to convert it to that radical form and then work it kind of in two separate problems. So if I looked at 9 to the 3 over 2, here's what my non-calculator brain would tell me. What is this the same thing as? What type of root? Square root. Do you have to put a 2 right there? No. Can you? Sure, if you want to. I don't care. I'm not going to judge you for that, okay? It's an even root, though, okay? Of, what's the base? 9, okay? Even roots, we can only take positive numbers in there. And then we're going to raise that to a third power, okay? This is the way I would do it non-calculator. Do you know what the square root of 9 is? 3. I hope so. It is 3. Then we raise that to the third. What is 3 to the third power? 3 times 3 times 3 is 27. And this is my answer. So I'm going to write this phrase here. Root, then raise. When you don't have a calculator, it is easier to do it in that order. Technically, you do not have to do it in that order because it works either way. You don't have to write this, but let me show you. If you thought of this problem as 9 to the 3/2, remember I said it doesn't matter if this 3 goes outside of parentheses. It could also go under the radical. This is the same thing as the square root of 9 to the 3rd. But here's the thing. Are you more likely to know how to take the square root of 9 first or raise 9 to the 3rd power first? Do y'all know what 9 to the 3rd power is on the top of your head? No. I don't. Some of you might. Human calculators. What is it? 9 to the 3rd power. Whatever. 81 times 3 is it 729. Again, was that very easy to do without a calculator? No. Guess what I did last period? I used my calculator. Okay? 9 to the 3rd power is 729. And then I have to say, okay, what's the square root of 729? Well, guess what it's going to be? 27. So it works either way. But again, I keep going back to, you're not going to have a calculator. Root, then raise. And that's equal to 27. So either way, mathematically is correct. This way is easier. Root, then raise. Say it. Root, then raise. Okay? Before we do these examples, which if you are working ahead, I wouldn't work too far ahead because I'm going to change some of these. But I do want to show you, you don't get a calculator, but while I have this in front of me, I want to give you just some general knowledge of the calculator in case you're in a situation where you do get to use one, which is not next week. But we need to, I want to show you how to get a square root. Do you know how to get a square root in the calculator? We should. We've been doing that for a while. Second x squared, okay? Do you know how to get a cube root?
Yes.
It's very
pretty sure.
Let me show you how to do that. Do you see this button right here that says math?
Yes.
Okay? Are you listening? This is good to know how to do. There's a math button on your calculator. It's just below alpha. It says math right here. If you look, number 4, it says cube root. That's if you specifically want a cube root. It's math 4. Okay, and then you press enter. You can put a number in there. What are we going to take a cube root of? I don't know, 27. And then we get a number there. You can also, in math, take any type of root. If you look at option number 5, I know it might be kind of small for you, but option number 5 says X root. So you would get a little box, and then you could be like, oh, I really want to know what the 5th root of, I don't know, 32 is. And then it will give you that there. So food for thought. You don't get this on your test, so haha. Well, also, reasons why you don't get on your test, because you could do 9 to the 3 half, 9, caret, 3 halves, and it will tell you really fast that that's 27. But this is advanced algebra 2, and you need to know how to do this with that big old brain of yours, okay? So here we go. Last little group of problems are, I'm going to kind of draw a separation here because I kind of do these as a simplify, and we'll talk about those in a minute. But let's talk about evaluate, because I will ask you to evaluate on your CFU, on your homework, on your test. You're also going to have to evaluate to do your solving. Without a calculator, what makes this easier, I think, is to go to the radical notation and then do your mental math. So this first one, we already put it in your radical notation. You're welcome. What is the 4th root of 16? 2. Very good. We need to know that. 2 times 2 times 2 times 2 gives us 16. So then I need to raise 2 to the 7th power. Now I know that's not on the list, but that's okay. It's 128. Very good. The last thing on your list is 2 to the 5th, which is 32. So that means 2 to the 6th is? That means 2 to the 7th is? 128. And so there's my answer here. Okay? All right, we'll keep this one right here. -8 in parentheses to the 2/3 power. I'm going to make a note. Where is that negative inside of? So what does that mean? Is the negative a part of the base or is it not? It is. Negative is a part of the base because they were intentional and they wrapped it in parentheses. You need to be able to know the difference between the two. You've got a couple on your homework where it is in the base, a couple where it's not. Okay? So let's do the rewrite real quick. What type of root am I taking here? Cube root, because 3 is my denominator. What am I taking a cube root of? What's the base? -8. Is this allowed?
No. Yes.
Oh.
Yes.
Why?
Because it's a cube root.
Because it's odd. It's a cube root, okay? And then we're raising it to the 2nd power. Root, then raise. What is the cube root of -8? -2. Keeping it in parentheses. What is -2 to the 2nd power? +4.
Oh, that's kind of easy.
Okay? Why does it become positive?
Because negative times negative is positive.
Okay, what if it was -2 to the 3rd?
How do you know the cube
negative.
root of -8 is -2?
Because -2 times -2 times -2 is -8. That's one I would have memorized, for sure. I would just have the cubed root of 8. If it's positive, then it's +2. If it's negative, it's -2. But cube root of 8, that's a frequent one that you'll see. Okay? All right, 16 to the 1.5. We do this to you a few times on your homework. We don't have a rule about decimals. But what can you write 1.5 as? Not 1/2. 3/2. So you can write it as 16 to the 3/2.
How is it 3/2?
Because it's 1.5.
Oh.
Okay? So you're going to have to rewrite some decimals as fractions on your homework. You can handle it. So this becomes, no, they're like pretty straightforward. Okay? 3/2, what type of root is it? Change it. So how do you rewrite it? What type of root? Square root of 16 to the 3rd. What's the square root of 16? 4. What's 4 to the 3rd?
64.
Another frequent flyer. I would know that as well. Okay, I'm changing this problem.
No, I already did it.
I told y'all not to do it.
Yes, you can't do it anyway.
You can't do it, but I'm changing it to write it like this. -4 to the 3/2. Notice the negative is not in the parentheses.
Oh no.
So what does that mean?
So you do it at the very end, right?
The negative is not a part of the base. You are correct. You do that at the very end. I would probably write it like this. Negative, put parentheses, and keep the negative on the outside. What type of root am I taking?
Square.
Square root of?
4.
and then I'm raising it to the third. If you left that negative as a part of the base, could you do that problem?
No.
Why not?
Because you can't square negative.
The square root. And we're not going to go to imaginary land today. So what is the square root of 4? 2. What is 2 to the third? Then you've got that negative floating in the front. So what is your actual answer? Negative 8. Okay, squeeze in a problem for me right here. Okay. 125 to the negative 2/3. I know. That's why I'm writing it in, because I don't think you're going to like it. Okay, so we've talked about negatives in terms of the base, whether it's a part of the base or like this guy where it's really just like a negative 1 factor in the front. This base is positive no matter which way you look at it. I made the exponent negative. Now, here's the thing with this. If you aren't sure, the negative needs to stay with the numerator because you can't do like a negative cubed root thing. Like that doesn't make sense. So keep the base or the negative with the numerator. So let's just rewrite it first thing. I don't really deal with the negative till kind of the end. So if I were to rewrite this, again, sticking the negative at the top, what kind of root am I taking of 125? Cube root of 125. And then I'm raising it to the negative 2 power. Okay, what's the cube root of 125? A popular one. 5 to the negative 2 power. Now think back to the front page. I mentioned this. You can't have a negative exponent. So what do you do with that?
You do the 1
Flip it.
1/5.
You flip it. You move that base to the denominator and make the exponent positive.
Oh,
And what's 5 squared?
1/25.
What?
5 squared? Yeah.
Yep, but it's 1 over 5
Oh,
squared.
got it.
So why can't it not just be 25?
I'm almost done. I'm almost done. Okay?
Shut up.
Let's be nice, please. Okay, so as far as evaluating, again, there's a bunch of these you can see you're evaluating at the beginning. It's like 17 through 24. Really, 25 through 28 and these guys up here are like the questions that I'm about to do right here, okay? So we're almost done. Technically, you could say evaluate, but it's kind of like evaluate and simplify. So, like, the verbiage is kind of whatever. But you're not really going to see this as far as our solving next class. However, this is just good to know. And while we're talking about this rule, it makes sense to do it here. It's SAT-like. It's not very hard. It's a star-worthy. It's star-worthy, though, because you are going to need to do it again or see it again. But here's what we do with this. So we're simplifying / evaluating the 4th root of 16 x to the 8th y to the 4th. So these technically, the way I think about them is I can separate, my radical properties can say, I can separate this as the 4th root of 16 times the 4th root of x to the 8th times the 4th root of y to the 4th. Okay, it's a little bit tedious to kind of do all this work, but it helps me. So if it helps you, if you can do it in your head, great. If it helps you to write it out like me, also great. Okay, so I can separate those into individual 4th roots, and then I can just evaluate the numbers. What is the 4th root of 16? 2. We know that. Now, with the variables, I'm going to just rewrite them as fractional. Okay, so this is x to the what? 8 over 4, which is 2x squared. Okay, this is y to the 4 over 4, which is y. Done.
Wow.
Yes.
It looks like you could just take the squares inside the square root and divide it by like the number on the outside.
That is the shortcut. With the variables, yes, it's with the coefficients, so you have to actually root those. Okay. I think there was a slight mistake on this one right here. I think this is supposed to say y to the 12th. That's what I changed it in my last class. So just to make it a little bit different.
Just divide the square root thingy.
With the bases, yes. Yes. The variable bases. Okay. Look at this one right here. Square root of a to the 3rd, b to the 4th. I added a c to the 5th right here in my last class. I really didn't need to, but I was on the fly, and I didn't realize that I didn't need to it. But for consistency, we'll do that. It's okay if Well, let's just work this. We can write it as square root of a cubed, square root of b to the fourth, square root of c to the fifth. Again, I just threw an extra base in there just for funsies, okay? On a problem like this, if I were to rewrite a to the 3 over 2, can I do anything with that? No. So I would say just leave it in that fractional. Reduce the fraction if you can. I think there's one on your homework where you get like, I don't know, 5/10 or something. Reduce that. But if it stays as a fraction, that's okay. What about b? Is b going to stay as a fraction? No. It's going to become b squared. What about c? Is that going to stay a fraction? 5 over 2. And then that would be your answer. Okay? So work these two real quick. And then, like I said, you can go to your homework. You've got time. And y'all, your homework goes fast. It really does.
Why are 2x?
Whoa. Change it to a y.